Hello, my name is Joseph, and I'll be going over 3D printing basics and design tips. We'll start with what 3D printing is. So 3D printing is an additive manufacturing process where two-dimensional layers of material are deposited and joined to create 3D models. This is very different from subtractive manufacturing, where material is usually cut away from a solid block. The most common types of 3D printing processes are FDM, SLA, and SLS. We'll start with FDM. FDM is also known as fused deposition modeling, and it's the most common 3D printing process due to its low cost and ease of use. This process is usually done with a spool of filament, most likely plastic, which goes into an extruder that melts it to build the layers. It provides good quality prints at a low price, but doesn't always have the most precision and resolution. Now, SLA printing, also known as stereolithography, uses a vat of liquid resin and cures the layers with UV light. This process usually produces prints with better resolution, but it requires a lot more post-processing work. And then SLS, also known as selective laser sintering, uses a laser to sinter powder, usually metal, which fuses together to form parts. This process provides great resolution and is able to create very complex parts due to the bed of powder that it uses. It's also quite expensive. I will mainly be covering FDM printing as this is the best for quick prototyping and it's easy and cheap. Now, there are a few things to keep in mind when printing with an FDM printer. The first is that it will print layer by layer with a small line of plastic. This means that if you're trying to bridge a gap, the melted plastic could start to dip down and possibly ruin a print. Now, when designing, we want to avoid making bridges, so we can design either depending on orientation to reduce bridges, or just have the model be specifically designed to reduce the amount of bridges it has to do. Now, you can also resolve bridges with support material, but they add a ton of extra filament to be used, and it also takes up more time afterwards to post-process that. Now, the next thing to keep in mind is wall thickness. This will increase the strength of your print, but it can also use more filament and take longer. And if you don't need something to be super strong, you can always reduce the amount of filament used and the amount of time by reducing the wall thickness. But there's a certain point where the wall can't be thinner, and that's usually the point that the printer extruder is actually measured. So most commonly, it's 0.4 millimeters, and you never want to go below that wall because that will be one single wall width. Now that I have covered the basics of 3D printing, I will go over my design process to design for a part. Now I want to design a fan mount to sit on a foam core wall that has a filter on the other side. I will be using these brass inserts which can be put into the prints with a soldering iron, which I will show later. I want this to be easy to print and assemble. So the first step is to take measurements. Here I've shown off the measurements that I took. I've measured the outside of the fan, so how thick it is, and then I measured the inner diameter between the circles, the outer diameter between the circles, and then I have the measurements for the heat inserts, which usually comes provided when you buy them. The next thing I do is sketches. These will just be rough sketches. It helps to easily visualize the project that I'm trying to do, and I can see the dimensions all laid out. And so here I've shown the filter, which I measured. I designed how I want the fan to fit, where the fan will be held in with 4 screws to the print on the other side, and it will be held up with that foam core where it just uses clamping pressure. So once we finish the sketches, I'll go over to Fusion 360, which is my CAD software of choice. Now here we can see I started out with the rough outline of the fan. So this is the exact measurements. We can see we have 119 across. And then the next thing I did, I put a foam core wall there, which just uses the same circle and shows the screw holes in between. And from there, I can add on this design that I made, which is the filter holder, where the filter will sit inside right there, and this filter is held in by a wall, which are made up of circles, well, ellipses, to provide maximum airflow, but also like hold in that filter that I want to be sitting there. So once I design this model, now we have to actually get it ready for printing. So the model right now is not much use just being this 3D model. The printer can't understand this. So we have to divide it up into 2D layers. And so we use a slicer for that. So this is my slicer. It's the Prusa slicer. It's really good for all sorts of printers. And so I've imported my 3D model, and this is how I want to print it. And I designed it this way so it's easy to print. It doesn't require any supports because these overhangs right there are not, like, my printer can handle that, and most printers can because it's just 45 degrees. And so this one's easy to print and it doesn't take much time. And so I can slice this and we can see it takes an hour and 40 minutes. Now we can go over here and bring the layers down to see the actual individual layers that the printer is using. And we can see right here we have the infill pattern. Now the infill is important because you want to pick something that's structurally strong. So in my printer settings, there's infill, and we have grids currently selected. And strong ones are usually something like a triangle or a honeycomb. And gyroid is also a really strong print type, and you can see it's just overlapping spirals that merge together, which creates really strong prints without using much filament. And then we can also change how much infill percentage. So I was at 10 before, now I'm at 25. And you can see there's a lot more filament, which provides a lot more strength. But a lot of the time, this isn't quite needed. So I'm just going to leave it at 10% for now, and we can see how that turns out. So now we'll export this as G-code, which is the code that the printer runs on, and we'll go over to the printer. So you can see the printer building it up layer by layer as it produces the part that I want it to make. And it will extrude this filament from this nozzle, and it will be able to build the part up layer by layer. Okay, now I'm going to put in the heat inserts. So the way this works is you just set it in that hole that I already made with the measurements that I took. And I take the soldering iron and I just push it down, and the soldering iron heats up the brass, which in turn melts the plastic, which will push the brass insert down, and it'll form it into that plastic and form around it and create a really strong hold. Now you can see I've mounted it to the foam core wall. The 4 screws go through the fan, through the foam core, into those brass inserts that I just put in, and then on the other side, the print is just sitting out there with the filter and the filter holder. And that's how you create a simple design and the tips and tricks I've showed along the way.